Okay, lesson 65. We're going to learn how to solve these trigonometric equations that also have radicals in them. The first thing we want to do is to move this radical to a side by itself, like we do with all equations with radicals. So if I move it to the right, it'll become positive. Then, of course, I can get rid of the radical by squaring both sides. Now we have like terms, so I'll bring this one over here and add it to that one. And then, of course, divide by 4. And then I can take the square root of both sides. So I'll have the sine of x is equal to positive negative square root of 3, square root of 4 is 2. Okay, now I need to find for all the x's between 0 and 360 degrees. Now, since they're positive and negative, it's going to be in each quadrant. So in this case, x is going to be 60, and then 120, 240, and 300. But remember, you must check your answers because it has a radical. And when you do go back and check this, you'll find out that these do not work out. So you end up with just these two answers. Okay, so let's look at the next one, which is very similar, but it's the cosine function. So again, I will move this to the other side. Square both sides. Bring my like term over here. Divide by 4. And take the square root of both sides. Again, it's going to be in all 4 quadrants because it's positive and negative. So I'm going to have 30, and then 150, and then 210, and then 330. Again, you must check, and when you do, you find out that these do not work. So you only have these two as your answer. Okay? Okay, let's look at this last one, which is just to graph this log function. So whenever you're asked to graph a log function, you want to first graph the inverse function. So the inverse function of this is going to be the exponential function. So the first thing you do is you put it in exponential form, which is x equals 3 to the y. And then reverse your x and your y. Change them to the opposite. So then you graph this. This is what you're going to graph first, okay? So I'm going to come over here, I'm going to graph it. Now we know it's an exponential function, the basic one. So at 0 it's 1, at 1 it's 3, and that makes sense because we know it's supposed to look like this. Let's label those points. They become real important in a minute. Now, all inverse functions reflect over the line y equals x. Now that line looks like this. Goes through 0 on the y-axis, has a slope of 1 over 1. So y equals x. Now when they reflect over that line, that means the coordinates just reverse. So 0, 1 becomes 1, 0. 1, 3 becomes 3, 1. And that's what that's a little bit off there. Let's get that thing looking better. That's what it should look like. This is 3, 1. This is 1, 0, and this one is y equals log base 3 of x. Okay? Okay, let's look at the back. Okay, so we're going to do another one. So again, we're going to take this and we're going to change it to exponential form. So x is equal to 6 to the y. Then change your y's and your x's. Okay, so the rough sketch, we have multiple choice here, so it's going to be really rough this time, but it's going to look like an exponential, like this, right? And it's going to reflect. Now, the points are going to be 0, 1. At 0, you get a 1. At 1, you get a 6. So I'm looking for points like 6, 1 and 1, 0. So it's going to look, right? It'll be lower down here. So this is the one that looks like that. Because it's got to be pretty low to get to 6, 1, right? So your answer is D. I hope that was helpful.